In C, we're going to simplify this radical expression. And one thing we want to note with this expression is we have an index of 4, which is, and we have the powers 16 and 24s, and they are multiples of 4. This means there's a ratio involved in here, and we can probably simplify that. The other thing that we want to see here is that we have 256. Now, 256 is a power of 2. Okay, so this is, in fact, 2 to the power of 8. So I'm going to first of all rewrite that as a power of 8. So this is a fourth root, 2 to the power of 8. Now this power of 8 now also is related to the index of 4. So what's nice about this expression is that all the powers inside the index of 4 are related to root 4. In fact, they are going to be, we can use that ratio to work out that power. And this is not going to be a fractional power anymore or a radical. We're going to have whole number powers in the end. So we have x to the power of 5, so y to the power of 5. Now we could, at any point here, simplify this x squared and x. Okay, in fact, maybe I'll do that in my first step. I'm going to have x, and then for the next part here, I'm going to simplify this whole radical. And I can simplify that radical using that ratio of 4 to 8, which becomes 2 to 1, or 8 to 4 becomes 2 to 1. So we can simplify this into the fourth root of 2 to the power of 8 is 2 squared. The fourth root of x to the power of 16 is x4. The fourth root of y to the power of 24 is y to the power 6. So we've worked out that whole radical and we've ended up with whole number exponents, which is nice. The x's have been taken care of here on the outside, so I'm not going to deal with that x. And then we have y to the power of 5 in the denominator. So we can then combine things. I can leave that as 2 squared, but I'm going to work that out as 4. I have x to the power of 5, and then 5 divides cancels with 6 multiplies, so I have 1 multiply left over. So there's my final answer. Now I put a little star next to D because the problem with D is that this index of 5 doesn't work out very nicely with anything in here, except for this 96. Okay, now that is hard to see, and in fact it's really hard to see, is that 96 actually has a power 5 embedded in it. So I'm going to rewrite that as 3 times 32, and 32 really is 2 to the power of 5. So I'm going to put this off to the side here. 32 is equal to 2 to the power of 5. So that's kind of nice, but anything else that in that denominator of 5 is a root 5, there's no root 5 powers that are evident at the moment. Okay, but some will show up in a minute here. So I'm going to have a divide by 3, divide by x, and y to the power of 16. Okay, so I'm just going to work out the inside first. I can see that there's some things that cancel out. This power 3's cancel out. This 32, I'm going to rewrite that 32 with, this is going to be written as 2 to the power of 5. That x time, the negative power means divide, so I'm going to put that in the denominator. So I already have one divide in there, so I'm going to count 10 divides in the denominator. With the y's, we have 1 multiply 16 divide, so I have an extra 15 divide in the denominator. So at this point here, I've cleaned this up quite a bit, and now I'm going to deal with that root 5. Okay, so this index or root of 5 is related to those powers. Those are all multiples of 5, which means we can simplify them. And so I'm going to apply, we could do this in pieces, which is what I'm going to do. I'm just going to apply that root, that denominator 5, onto each one of those exponents. So then I'm going to end up with 2 to the power of 1. Oops, I'm going to, okay, and then just make sure that when I do that, I'm going to leave that negative 3 power on the outside. So I'm going to end up with 2 to the power 1. X, that power becomes power 10 to the 5th root, which is power 2. And then I end up with y to the power 15 to the power of 1/5, or root 5, is going to be power 3. Okay, so that 3 to 1 ratio exists. That 10 to 5 ratio becomes a 2 to 1 ratio. So now I've got whole number exponents. I've applied the root. I now just have that negative power 3. So I'm going to do this in 2 steps. You can do this in 1 step if you like, but I'm going to apply the negative first, and then I'm going to flip the fraction. So all my divides become times. My times becomes divide. And then now I've applied that negative. Okay, so that negative flips the fraction. Okay, so that negative flipped the fraction. So flip that fraction upside down. And then I can apply the negative power, the power 3, and my final answer becomes x to the power of 6, y to the power of 9, and then I'm going to leave this as 2 to the power 3, although I could work that out as 8. So there's